comparisons to share with us.
Yeah, thanks for the introduction. I'm Prakash Surya, came from the Linux world. I'm now working on illumos.
So does that mean you're safe or you're lost?
Well, it depends. So since I'm giving the illumos spiel, it's kind of hard to do that without getting into the history a little bit. So where does ZFS come from? In 2001 is kind of around the time development started. It was released in 2005 for OpenZFS. In 2010, illumos spawned as a fork of OpenZFS. I won't go into the details of why that happened. In 2013, OpenZFS was created. That's kind of why we're all looking for the ZFS aspect of it. Because of the history of ZFS, that it got started in Solaris environment, it's kind of, its home is in illumos, but it goes beyond history. I would say it feels at home also because of the close OS integration. Things like grub, you can move from ZFS on root really easily in illumos. There's NDB support for ZFS extensions from NDB, admin infrastructure. All of that just makes it feel at home in illumos. And now with OpenZFS, recently over the past few years, it's really grown beyond illumos, and that's an endeavor here. So to touch on the development model of illumos, there are committers that I guess are called advocates. So they actually merge to the illumos truth. They don't necessarily ensure that it's correct all the time. They rely on the advocates rely on reviewers to review the changes. So the reviewers, sometimes the advocates are reviewers, sometimes just trusted developers review the code, and the advocates rely on them. The reviewers make sure the code is correct, good design, all that kind of thing. There's no explicit releases on illumos, so that means every change must be release quality. We can't, we don't want to merge something that we know has a bug and just say we'll fix it up before the release, because every change is a release in a sense. One thing that I wanted to note is the development tools and processes are a little bit difficult. I think everyone outside of illumos might tend to agree. The way to write a change, compile the change, deploy it, test it on the Linux system or something, you're not from this environment, it's difficult to kind of learn how to do that and get up to speed. So, yeah, it's just numbers. I wanted to touch a little bit, now that I'm in the upstream illumos community, we all want to facilitate everybody contributing back to us. Not necessarily just because we want your changes, but we want it to facilitate collaboration between all of the distros. And as of right now, illumos is considered the upstream repository. Everyone pulls our changes down. So we encourage you guys to push your changes out to us, and everyone can pull them down, and everyone gets the same changes, and it just makes everybody else's life easier. Everyone maintains everyone else's changes. It's difficult to do that right now. As I mentioned before, the way to make a change, test a change, deploy a change is difficult on illumos if you're not already an expert. And we'd like to make that easier. That's an open question. I'm not here with any answers right now, One is ZFS on illumos is tightly integrated into illumos. And illumos is much more than just ZFS. ZFS on Linux is really isolated and there's little dependency, so it's really easy to download the source code, build it, compile it, load it on, say, my Linux line. Illumos is more difficult because not only do you rebuild the ZFS, but you have to rebuild the kernel, the libraries, and much more. And that takes longer to build, and it makes it more difficult to set up a build environment. So this overhead for a single lone developer can be prohibitive. And I think we don't want to make that easier for a single person to just enter the community, build, write a change, build it, test it really quickly without a large overhead. Some random benchmarks that I ran, like a full illumos build on our internal build server took about 2 hours. If I was just building the ZFS code, it took about 6 minutes. If I built the ZFS on Linux build, the SPO, and the ZFS code on my laptop, on my Linux laptop, that took about 3 minutes. So that kind of shows the disparity when building the full illumos tree, it can take hours, and if you're just building ZFS, it can take minutes. So we like to, make it easier to build ZFS on Linux, and that's another question. The kernel tools on Illumos, in general, I think are better. That's my subjective perspective. I found MDB to be really, really cool. I used Crash a lot when I was at Linux, which is the Linux kernel debugger, I guess. It's the analysis tool. It seems like it could be as cool as MDB, but it's not. I think that goes back to the history. MDB and ZFS are in the same repo. They share similar heritage. The really nice thing about MDB is pipelines and walkers. That was one of them. When I first, got with some developers and saw how they debug stuff on Illumos, it was enlightening to say this. It felt like I had the power of an SQL prompt to just query the system with Crash Johnson. Here's what I want to know. Go down, get it, tell me what it is, tell me what I want. With Crash, it would take me half a day. With MDB, it took 5 minutes or less if I already knew how to use it. So D commands are really nice. You can extend them. You can add ZFS specific D commands. And touches on the fact that they live in the same source tree. So when a ZFS feature is introduced, you can then change MDB and add a new D command to debug that feature. So you can have ZFS specific extensions. That'd be much more difficult to Crash because they live in different source trees. This is just some examples of certain D commands that I found to be really cool and useful. The walkers are cool. Find base stacks on Crash. It doesn't filter stacks for you based on modules or stack trace, where MDB has that built in. This one, so I'll touch on those in a couple of slides at the end. One thing that I missed is there's no line number resolution. So if on Linux, a lot of times you have a stack trace and an offset, and you can jump into MDB or GDB and get the exact line number that, say, an assert hit and you got a function and an offset, you get the exact line number in the source. That's not available to me anymore, so I got to look at the disassembly for the function, and that's not nearly as nice. KMDB is cool. That's kind of essential when you're running on root and I make a change in the our page cache and I deadlock the system before it even moves and gets into a run. It's not as essential if you're not running on root. Like I wasn't writing experimental changes on my Linux ZFS file system, but it is cool that you can step through the running kernel console using KMDB, and then we did that on Linux. Dtrace is also cool. I think most people are probably more familiar with Dtrace. I don't know illumos, that what I've noticed is that people involved in ZFS on illumos tend to be more informed. You know, they understand architecture or the internals or just how to use it a little bit more. It's not some random person just grabbing a couple hard drives from their garage and throwing it in the system. You know, putting a terabyte SSD on a 2 gig system and seeing that it doesn't work. But that also means there's less people testing on random stuff, on random distributions, on random hardware, on random workloads, you know, whatever they care about. So while we get less people making bug reports and stuff, you know, we just probably shouldn't do that right now because everyone knows about the issue. You get less people testing new features or even old features that, you know, one company may not really use much. So that's good. The ZFS test suite is available on Windows. I like running that. That's really nice to make sure I don't break something. But there's no XFS test that I can run. There's no file bench that the ZFS test suite uses. So, or the ZFS and Windows test suite uses. So again, benefits and drawbacks. I just wanted to show some examples because before I came to Delphix, I never really ran MDB, so I wasn't aware of how powerful and how cool it was. So this is just an example of running the slot command. I ran all these on the live system and run it on a crash dump as well. And this just shows some information about the slot, the videos, and the pool. You get two pools here, the root pool and the tanks with different details. This one shows a metaslab histogram statistics. So you can run that on a crash dump, you can run it on the live system. Can't do that on a crash dump in Linux. So that's really cool. You can see what the metaslab group looks like as far as the histograms and the spaces. This is an example of the debug command. This is like a ZFS extension to MDB. Again, you can print the debugs that are in the cache and get whatever kind of information you want out of them. This one just prints the first debug and that does some of the object, the offset size, you know, all that kind of stuff. This pipes it to the debug command, so it's listing every debug on the system and then formats it a specific way to make it useful and easy to digest. What it is really cool if you have an address like a pointer and you just want to know what it is. There's a what is command. If you have certain K-mem left or not, you can get the backtrace of, you know, where it's allocated, where it's free, also use that for free, or, you know, all kinds of debug scenarios. And that's kind of just all I got. Any questions?
So on the previous report, at least the spectrologic, I don't think we've upstreamed this particular change yet. We added similar K-mem type flags so we could do stack stuff.
Yeah.
We found that we had to be pretty careful about what kinds of workloads we could actually run in and use that.
Yeah.
Are there similar restrictions on illumos, or do you have secret sauce to fix that?
I'm so new that I'm not even.
For the most part, it just works.
Yeah.
It uses a little bit more memory. I think that's the main thing because every thing that you allocate, it allocates another buffer for the traceback. So you can occasionally get into very situated on memory machines, but for the most part, it just works.
Usually move the time freeze by a lot.
Well, good times and everything else
seen it take an order of magnitude more memory for allocations, but I guess that comes with the territory of all the different.
That's the typically use case. You can kind of turn it down and drop some of the more expensive things.
Yeah.
But for debugging, it's really just to have like a whole suite of like.
So in terms of ZFS test and ZFS, is there like any protocol trying to make it more stable and automate things right now? There's a big test with ZFS, which is very outdated and doesn't work with that. Is there any official work plan like that to get this working?
I'm not sure I have to conclude.
Oh.